at this PowerPoint right here, one of the things that we had mentioned that pressure and what creates pressures are going to help materials move in or out of the capillaries. So we sort of just took a peek at this, and one of the things that let's think about for a second, don't forget that this is a capillary, and it's feeding, I don't know if you guys can kind of see the cells that they're trying to represent around this capillary bed, okay? And one of the things about it, they're trying to show us blood flow by way of my arterial end to the venous end. One of the things that we're going to find that we're going to have pressures in the tissues, and then we have pressures within the bloodstream also. And because we have these pressures, as well as the fact that on the arterial end, we still have our blood pressure, because remember, if we think about that 120/80, by the time we get to the capillary end, that pressure is now down to about 30, all right, at that arterial end in the capillary bed. So we've got the ability for there to be pressure from the blood pressure itself, but we're going to find that there are pressures in the tissues as well as we go from the arterial to the venous. The goal on the arterial end, move out materials that are needed for the cells. The venous end, get rid of the waste. So the way that you can read this slide right here, they're letting us know that we have our hydrostatics, okay? The water, meaning we've got water in the tissues as well as in the blood. So it's telling us in our blood we have a hydrostatic pressure. In the interstitial, does everybody remember what that term means? Between our extracellular fluid, okay? So it's telling me that in my blood flow, as well as in my tissues, I have forces of water. We've already mentioned that materials like to move down their pressure gradient. What do you notice about the pressure gradient for the water on the arterial versus the venous end?
Your arterial is higher.
My arterial end is higher. Venous end, lower. So that is going to allow movement of fluids. Now, the other part that we have to remember creating pressures is the colloids or colloid. Do you happen to remember what a colloid is? Do what, Marlisha? A red blood cell is part of a colloid, but what is that actually making up? Because it its properties. That's what happens when you create a colloid. A colloid is going to be the products that are in the fluid that have kept their properties. They're still a piece, so to speak. So that means I have pressure both in the blood as well as the tissues that are going to affect movement of materials. In the grand scheme of things, under normal conditions, the tissues, if they have been active, those cells, they're going to have a demand for materials. So therefore, on the arterial end, pressure's high, okay? So therefore, materials would move out of the blood. Because they've been busy, they've created waste. Waste are going to be high in the tissue fluid, low in the blood, and once again, allow for the movement. So under normal conditions, we would see materials out, waste in, and keep going. Any questions? The one part about the movement is making sure that we keep our cells, whether we're talking about the cells here in the tissues or cells that are making up blood vessels as well as material in the blood vessel, is that we're keeping our systems under isotonic conditions. So that is why this movement of materials, movement of water becomes important. We are animal cells, so therefore our cells only have a plasma membrane. They're squishy. We take them out of the isotonic conditions, they're going to die. Movement of water and materials becomes important. Things can and do go wrong. When we leave behind any type of fluid in a tissue, it's called edema. Sure, you guys have heard of it, okay? Basically, the fluid is entering that tissue faster than it's reabsorbed on the venous end. The biggest reasons for buildup of the fluid in the tissue: kidney failure, right ventricle failure, heart conditions, okay? We can have, for example, protein deficiencies, which happens a lot in liver diseases, famine. Have you ever seen the pictures of people from severely famine countries? Bellies are very big, but arms, legs, just skin and bones, okay? This is due to their protein deficiencies, and it's a buildup of the fluid, like in their abdomen, because they don't have the proper nutrients and proper movement of materials through the blood to the tissues and that sort of thing. Their body's breaking down muscle to try to help provide energy, that sort of thing. And so fluid builds up in their abdomen, and it's the ascites. It's very similar to what happens in cirrhosis, For example, if you've ever known anybody with any type of liver conditions, the belly tends to get very rounded and it's hard. I don't know if y'all ever known anybody with it, but it's almost like it's brick hard, and it's the fluid that is built up in the abdomen, and it's called ascites. When we have an obstruction for lymph, wait a minute, I haven't talked about that yet. That comes up, I think, in the next chapter. Lymph. We have these things called lymph nodes. All right. When the best example I can give, women who have to have mastectomies due to like breast cancer, a lot of times they have to go in and remove lymph nodes, especially from the axillary area. And this causes the drainage because lymph vessels do help to drain fluid into tissues, but they can't because they're now obstructed because those lymph nodes have been removed. So people who've had mastectomies usually have to, at nighttime, put those compression arm socks on their arms because during the day, all the fluid built up in the tissues, and at night they have to push it back to get it back into circulation and get it out. So there can be surgeries and that sort of thing that are obstructing the movement of this fluid back into the vessels for the body to get rid of it. So the lymph system kind of gets important. Oops, typo. Back to the heart. Okay. So the last thing that we end up with, I think, in this chapter, it might be a part 5, I can't remember. Venous return, meaning this fluid back to the heart, and then what is circulatory shock? The venous return, we move the fluids that have circulated to the tissues, to the cells, this sort of thing, we move it back to the heart, okay? Arteries take it away, veins bring it back. We, for the pressure gradient we have on that arterial side, that pressure very high, but once we get to the venous side, pressures are very low. Anything that gets generated by the heart, it's only about 10 millimeters of mercury of pressure. So it's very low on the venous side. Gravity, well, yeah, from head to the heart level, but from the heart level down, the body has to work against gravity. So we depend on skeletal muscle. We have what's called our thoracic or our respiratory pump. One of the ways that within the thoracic cavity that we return the fluid to the heart, every time we breathe, we're moving skeletal muscle. We've got those intercostal muscles, we've got the diaphragm, and that causes pressure on these vessels to return the fluid. And then when we have the heart beat, do you guys remember tendinous cords, okay, to the valves of the heart that are attached to the papillary muscles, just a little bit of a reminder there. When they flap, there is a little bit of suction created. Not a lot, but just a little bit. When we have this flow be insufficient to meet our metabolic needs, it's termed circulatory shock. If I don't have output and